All right, go to the first question. Let me see whether I can do it without writing. What's the formula? What are the quantities given? The mass? The initial velocity? Somebody tell me, what's the initial velocity? 39. What's the final? Now you get to be awake, more awake than that in physics. It's not 52. It's negative 52 because it's being hit straight back. If you take the 39 as positive, then the 52 must be negative. One of them must be negative. Do you see that? So underline that part of the sentence. That's why I selected that question. Hit straight back. And then you got to find the force between the ball and the bat. And the formula that you'll use is F delta T is equal to M times V minus V naught. F times delta T is M times V minus V naught. Isn't this a familiar formula? Because force is mass times, if I bring it to the other side, you'll have F is equal to mass V minus V naught by delta T, right? And find the force. So in this case, in the first case, you got 4,398 Newton. 4,398 Newton, which is the force between the ball and the bat. MB, 85 kilogram. VA is 4.1 meter per second. VB, Julianne, what's VB? 5.5 meter per second. What are you supposed to find? What happens to them after the tackle? Just visualize. In the tackle, what's the cornerback doing? And they collide, and what's he trying to do? He's trying to stop the other guy from getting a touchdown, isn't it? So what's he going to do? He's trying to stop him, but you know that the other guy is heavier, running faster. Are you with me? So what's happening now? They'll be together and moving with the same velocity. So VA prime is the same as VB prime. So VA prime is equal to VB prime. So you could either use VA prime or VB prime in that formula and finish it. So 857 is equal to 180 times the velocity, and then when you divide by 180, you get 4.76 meter per second. That will be the common velocity with which they move forward. 4.76 meter per second. In question 3, MA is 9,300 kilogram. And what are you asked to find? Yeah, MB. You have to find MB. VA is 15. What's VB? 0. Because it says at rest. People don't see it, you know. People look for numbers and miss it. The second car is initially at rest. So VA is 15 meter per second. VB is 0. And it's given that VA prime is equal to VB prime is equal to how much? 6 meter per second. Okay, so that is 6 meter per second. And then use the formula MAVA plus MBVB is equal to MA plus MBVA prime. Plug in the numbers. You will get 9,300 times 15. Don't you get that? Yeah, I'm moving on. Plus 0 is equal to 9,300 plus MB times 6. On the left hand side, you get 139,500. And on the right hand side, you get 55,800 plus 6 times MB. Bring that over to the left and subtract. You get 83,700. Divide that by 6 and you get your final answer as 13,950 kilogram. So the mass of the second car was 13,950 kilogram. So the mass MA is 3,800 kilogram, VA is 8.6 meter per second, right? And see that the mass of snow filling the car after 90 minutes is how much?
41.3.
All right, you found the mass of the snow. Mass of snow was 3.5 times 90, isn't it? Which is 315 kilograms. And then you add the 315 kilograms to 3,800 to give you 4,115 kilograms. That's your new mass. So now you set MAVA is equal to MBVB. That's all. So you will get 3,800 times 8.6 is equal to what? 4,115 times VB. And the final answer is 7.94 meter per second. 7.94 meter per second. So here we go. MA is given in grams. You got to change it into kilograms. So you would get 0.023 kilogram. VA is the velocity of the bullet, which is 230 meter per second. MB is the mass of the block, 2 kilogram. And VB is 0 because it's stationary. You see the word stationary means not moving. Okay. And VA prime, the bullet comes out with a velocity of how much? 170 meter per second. And you have to find VB prime. So use the principle of conservation of momentum. MAVA plus MBVB is equal to MAVA prime plus MBVB prime. Plug in the numbers. 0.023 times 230 plus 0, right, is equal to 0.023 times 170 plus, what's the mass? 2 times VB prime. You get 5.29 is equal to 3.91 plus 2 VB prime. You take the difference and you would get 5.29 minus 3.91 is equal to 2 VB prime. The difference is 1.38, and then you divide by 2, you would get the answer as how much? 69? 0.69 meter per second. So impulse is either given by F dot delta T or it's given by mass times change in velocity. And in this case, we are going to use this. The mass is 0.045 multiplied by 45 minus 0, and you get 0.045 times 45, which is 2.025 Newton second, isn't it? Okay, now the B part. How will you find the B part? Use the other formula. Use the other formula for impulses. F dot or F times delta T, you already got 2.025, so 2.025 is equal to F times the time, so divide. Five, 7, 8.5 Newton. That is the answer to that question. So the mass of this car is 1,500 kilogram. The initial velocity is 50 kilometer per hour, which is 50 times 5 divided by 18, which gives you 13.89 meter per second. The final velocity is, of course, what? 0. isn't it? And the time is really small, 0.15 seconds, and you use the formula for force, this one. Again, use F delta T is mass times change in velocity. Put them together, and you get the formula for force, like I've written here. Mass times change in velocity by time. Same thing. Plug in the numbers, you get 1500 times 13.89 divided by 0.15. And the answer is 138900. 138,900 newtons. So force is mass times acceleration. So acceleration is force divided by mass. Put those numbers. 138,900 divided by 1500 gives you 98.6 meter per second squared. Actually, it's supposed to be negative, isn't it? Because it's an opposing force. Because it's slowing down. Isn't the car slowing down? So it's supposed to be negative. So kindly put a negative for that force. And also put a negative for your final acceleration, please. Yeah, question number 8. The two balls have the same mass. And the first one is moving at 2 meters per second. The second one is moving in the opposite direction, and that's why it's negative. And we had to find their final velocities after collision. Now, because it's a perfectly elastic collision, we can use this formula. VA minus VB is VB prime minus VA prime. And so the left-hand side becomes 2 negative 3, which is 5, is equal to VB prime minus VA prime. So that's equation number 1. Now, applying the principle of conservation of momentum, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. So, taking that, because their masses are equal, each mass is taken as m. So that gives us 2m minus 3m is equal to m times VA prime plus m times VB prime. So negative 1m is equal to that. Actually, the masses can be cancelled. That gives us equation 2. Adding equation 1 with equation 2, well, we'll get rid of VB prime. And we'll actually get rid of VA prime, and that will give you the value of VB prime. Substitute this back into equation 1 to get VA prime is equal to minus 3 meters per second. So you see that the velocities have switched because they have equal masses, and it's perfectly elastic. Question 9. This car A has 450 kilogram, moving at 4.5 meters per second. Car B 3.7 meters per second and has a mass 550. Again, it's an elastic collision. Therefore, we can use VA minus VB is equal to VB prime minus VA prime. Plugging in the numbers on the left hand side, we get 0.8 is equal to VB prime minus VA prime. Call that equation 1. Or we can even switch and write VB prime is equal to VA prime plus 0.8, and that's one equation. Now applying conservation of momentum, and plugging in the numbers, gives us this equation, which can be simplified as given. No change on the right hand side. The left hand side adds up to 4060. And remember, we are also substituting for VB prime. So 4060 is 450 VA prime, and then 550 VA prime as you open the parenthesis. And then you got 550 times 0.8 is 440. Add these two numbers to get 1000. Take the 440 to the other side. You get 3620 is this. Therefore, BA prime is 3.62. Now you can get back the value of VB prime simply by plugging the value VA prime as 4.42 meter per second. Question number 10. That is the 3.6 kilogram pendulum, and as the bullet is fired in it, it takes up a new position. X is the linear displacement along the x-axis, and y is the height that is lifted up. The mass of the bullet is 0.028. Mass of the block is 3.6 kilogram. Bullet moving at 230 meters per second, and initially the block is at rest. We know that they stick together, the bullet gets stuck in the wooden block, so they have the same velocity. That's why VA prime is equal to VB prime. And then applying the law of conservation of momentum, we get this equation, plug in the numbers. Second factor is 0. And solve that to get VA prime is equal to 1.78 meter per second. Now if you call the positions A and B, kinetic energy at A is equal to the potential energy at B. And therefore 1/2 times the total mass times the velocity squared is equal to mgh, mgy in this case, and from this equation we can find y. Y is 0.16 meter. Now going back to the figure, this is 2.8 meter, and this is 2.8 minus 16, which is 2.64. So you can use the Pythagorean theorem, 2.64 squared plus x squared is 2.8 squared, from which x squared can be found, and then the square root can be taken to find x. So x is equal to 0.4, 0.8, that's x squared, and x is 0.93 meter. In the 11th question, The sports car has mass 920. We have to find its velocity. The SUV is of 2300 kilogram and it's not moving. This is a multi-step problem. First, friction is mu times Fn, which is mu times the sum of the masses times G. Plug in the numbers to get friction as 25240 newtons. So since this is only force acting, we can find the acceleration. In fact, it's a deceleration as force divided by total mass, which comes out to be 7.84 meter per second squared. We put a negative to that because the force is also negative. Now delta x is 2.8 meter. Final velocity is 0, and so we can find the initial velocity with which both start moving after the collision. And this can be done using this formula. Plug the numbers into it to get V0 squared is negative 2 times A, which is 7.84 times 2.8. Two negatives make a positive, and you get V0 is 6.63 meter per second. Now that's the velocity with which both began moving after the collision. So using the conservation of momentum, we can find the velocity of the sports car. Just plugging in the numbers. Just made space there. And that calculates out to be 23.19 meter per second. Thank you. The rest of the problems will be done in another section.